There are few words in medicine that land harder than this one: cancer. It doesn't announce itself, it doesn't warn you. Deep inside your body, one cell makes a critical mistake, then another and another. Until one afternoon, sitting in a white room under fluorescent light, a doctor looks you in the eyes and says those words. Cancer destroys timelines. It collapses futures. It tears through families without mercy or logic. It strikes the young. It strikes the old. It doesn't negotiate with how much you still have left to give. By any measure, cancer is among the most devastating forces in nature. And here's the part most people get wrong. It didn't start with modern life. The common assumption is that cancer is a product of our era. Cigarettes, processed food, industrial chemicals, screens, sedentary living, those things absolutely matter. But the origin story goes back far further. In 2016, a research team examining fossils from a South African cave made a striking discovery. A foot bone, belonging to a human ancestor, either Australopithecus or early Homo, was dated at roughly 1.7 million years old. And embedded in that ancient bone was clear evidence of osteosarcoma, a malignant bone cancer. This was not trauma, not a fracture, not a healed wound. This was a tumor, growing in a creature that predated our species entirely. The same research also identified a benign spinal growth from a skeleton of comparable age. These are classified as neoplasms, abnormal tissue growths. Finding them in fossils nearly 2 million years old tells us something impossible to ignore. Cancer is not a new condition. Cancer is ancient. Now, the fossil record has a serious limitation. Cancer predominantly targets soft tissue, organs, skin, blood, glands. Soft tissue breaks down. It doesn't survive millions of years. What survives is bone. So everything we find in fossils represents only the smallest fraction of cancers that actually existed. Scientists describe this as preservation bias. We can only see what left a permanent mark on hard tissue. That's why ancient mummies have been so scientifically valuable. Mummification preserves soft tissue, and what researchers have found inside has rewritten assumptions. Using CT scans and advanced imaging technology, scientists have detected tumors in Egyptian mummies thousands of years old. One study examined over 100 mummies and found confirmed evidence of cancer in multiple specimens. The physical evidence doesn't stand alone. Ancient civilizations also wrote about what they were observing. The Edwin Smith Papyrus in Egyptian medical texts estimated to date to around 1600 BCE contains detailed descriptions of breast tumors. The author's conclusion was blunt: there is no treatment. That line, written by a physician nearly 4,000 years ago, carries enormous weight. Around 400 BCE, the Greek physician Hippocrates gave this condition a name that stuck across centuries. He called it karkinos, the Greek word for crab. He observed that the swollen vessels surrounding a tumor resembled crab legs radiating outward from a body. The Roman physician Celsus later carried that word into Latin as cancer, the exact term still used globally today. Across multiple civilizations and thousands of years, people were watching, documenting, and attempting to explain the same disease. They simply lacked the tools to understand why. To understand why cancer has always existed, you need to understand what it actually is at the cellular level. Cancer begins with a mutation, a point where the DNA inside a cell is copied incorrectly or damaged in a way the body can't repair. Under normal circumstances, the body identifies and eliminates these errors. But occasionally, a mutated cell escapes that system. It begins replicating without stopping. It builds mass. It invades neighboring tissue. Here's the key point. Mutations are not caused by modern life. They happen naturally every time a cell divides. They are a built-in feature and flaw of biological life itself. More cells, more divisions, more time alive, more chances for an error to slip through. This is true for every organism that has cells that replicate. Dinosaurs developed cancer. Ancient fish developed cancer. Even trees formed cancerous growths. So did prehistoric humans get cancer less frequently? Probably, but not for reasons most people cite. The primary factor was life expectancy. Most ancient humans never reached 40. Infection, predators, Childbirth complications, starvation, these were the causes of death. Prehistoric life expectancy averaged somewhere between 25 and 35 years, and cancer is predominantly a disease of aging. The majority of cancers develop after age 50. If you die at 28 from a wound that gets infected, you never live long enough for a tumor to become a threat. Ancient people also had different risk profiles. No tobacco, no synthetic chemical exposure, diets based on whole, unprocessed foods, consistent physical activity as a daily requirement for survival. These factors reduce specific cancer risks significantly, but they had their own exposures too. Chronic smoke, inhalation from cooking fires, parasitic infections that trigger long-term inflammation, unprotected sun exposure over entire lifetimes. Ancient life was not a cancer-free environment. People were simply dying of other causes before cancer had time to surface. So why does cancer feel so omnipresent today? Two major reasons. First, longevity. Modern medicine has dramatically reduced the infectious and traumatic causes of early death. More people now live into their 60s, 70s, and 80s, precisely the age window where cancer is most likely to develop. Second, detection. We now have the imaging technology to identify a tumor the size of a fingernail deep inside the human body. Ancient physicians could only diagnose what they could see or feel on the body's surface. Most internal cancers went entirely undetected. Modern lifestyle factors do add real risk on top of that baseline. Tobacco is directly tied to cancers of the lung, throat, and mouth. Processed red meat consumption is linked to colorectal cancer. Obesity is connected to more than a dozen cancer types. Chronic UV radiation drives skin cancer rates. These are real contributors, but they add to an ancient foundation, they don't create it. Understanding the deep history of cancer is actually scientifically useful. If cancer has been woven into multicellular life for millions of years, it means evolution has been working on the problem too. Elephants, for instance, carry multiple extra copies of TP53, a gene that suppresses tumor development. Researchers are actively studying those genetic mechanisms as a potential pathway for human treatments. The fossil record also gives scientists a timeline. By comparing ancient bone tumors to contemporary cases, researchers can trace how certain cancers evolve and identify which environmental conditions accelerate them. Cancer is not only a medical challenge, it is an evolutionary one, and tracing it back to its origins is part of learning how to defeat it. A 1.7 million year old bone, a tumor in a creature that had no language, no fire, no civilization. Cancer was already there. It has been humanity's oldest biological adversary. And for the first time in that extraordinary timeline, we are finally building tools powerful enough to fight back.